Statistics Canada estimates the population growth of Canadian cities, provinces, and territories. Looking at Nunavut, it is expected to grow annually by 0.8%. So this is a really good question because it's going to review and help us review our understanding of percentages, what they mean, how you work with percentages mathematically, and also connect to sequences, geometric sequences. So we've got 2009, we start with 30,000. I'm going to call that term 1 in 2009. I want to figure out what term 2 is. Well, first of all, we have to know that term 2 should be bigger because it says it's growing. Growing annually means it's getting bigger. So having a basic understanding of that in our head is important. But how do we work with percentages? If you wanted to find a percentage of something, like what is 3% of 80? How would you do that mathematically? Because we want to do 0.8% growth, so we have to figure out 0.8% of 30,000. How do we do a percent of? So I want to do 3%, what number did I say, 80? How do I do that mathematically?
Percent means of 100.
Right.
It's 3. Right, you said 3.
Yeah.
Over.
So first of all, we change that percentage to either a fraction or a decimal, right? So everybody knows that like 3% is actually 3 out of 100, which is 0.03. So if I want to find 3% of 80, I'm going to take 80, and then how do I use the 0.03? And multiply. So the of part, in language, when we say of, 3% of 80, if I say it in that direction, 3%, first of all, that's a decimal, 0.03. 3% of 80 would be 2.4. I want to find 0.8%. So how would I change 0.8% to a decimal? Divided by 100, which means move that decimal 2 places over. 0.8% of 30,000, so that of means multiply, gives me 240. Does that mean there's going to be 240 people in Nunavut? No. That's how much it increased by. So we had 30,000, and now we're going to have 30,240. This I'm going to call my term 2. This would be 2010. Now, an interesting thing happens with percentages. And maybe you know this already, because there is one percentage that you get hit with often in your life. Do you know which percentage that is? Where do you run into percentages? Every time, there's not a single person in here that this has not affected.
12% tax.
12% tax. Okay? Why is it 12%?
5 and 7, I think.
5% is called, which one's that one?
Yes.
5% is the GST. And I just found out that the 7%, which used to be called PST, apparently they changed the name of it. It's now RST. Retail sales tax. Maybe so you don't get mad at the province anymore? I don't know. If it used to be provincial sales tax, then you'd be like, tax, anger. What should I be angry at? The province. Now maybe they change the name, you'll be like, I'm mad at the store. The store doesn't get money. So I don't know. Anyways, so we have that 12%. So you're like, you go to Dollarama, you pick up a chocolate bar that's $1, you have $1, and you're about to be disappointed. Because you get to the end and it's actually $1.12. But yeah, you get to save 2 cents and happy dance there, right? Because they get to round to the nearest 5 cents. So what ends up happening is if you were buying something for $37.99, found a really nice new pair of shoes on sale, you're super excited, how much is it going to cost you in the end? There's 2 ways you could do this. You could say, I could calculate 12%, that's how much I have to pay in taxes, and then I could add that to my $37.99 and find out I have to pay $42.54. But mathematically, this is a lot quicker. 37.99 times what? 1.12. Gives me the right value right away. The reason that works is what you're really doing when you times by 1.12, you're really multiplying by 1 plus 0.12, which is obviously 1.12. But if I write it this way and I distribute, do you see that the 37.99 times the 1 is just your 37.99 that you started with, plus how much tax you have to pay. But combining it together is super nice, and we can use that strategy here. Our R value is 1.008. If you want to increase something by a percentage, it's going to be 1 plus that. If you want to decrease something by a percentage, it's going to be 1 minus that. So with this, I could find term 3, 2011, by taking my, figure this out, I could take my 30,240 and multiply by 1.008 and find out that I have 30,481.92. I'm going to show you something cool with calculators. This will work on scientific calculators and graphing calculators. If I want to do that again, you notice that you can just push times and it automatically takes your answer from before and 1.008. Right? This was 2011, this is 2012. And then if you just push, once you've done that once, you can just push enter again. And it'll just say, you want to do the same thing you did last time again? And we've got 2013. So I could figure out 2013 just by multiplying. What do we get as an answer? 30971.5. Uh-oh. Okay. How are we feeling about that 0.5?
So half a person.
Half a person?
About cut in half.
So, yeah, we could think of cut in half. That's a very disturbing image. I guess, when is a person a person? Like, if someone's pregnant, is that 2 people already? We get an, oh, this is like an ethical debate, right? This is like a baby halfway born? Maybe? Exactly. I think that's why they said round to the nearest thousand, so we don't get into any ethical debates. 2013 is going to be to the nearest 1,000, 31,000. No ethical debates about people being cut in half or half a baby or anything like that, where you have to get into difficult situations. Which term would the 2013 be? Term what? Term 5. Now, if we want to find in part B, 2049, right? I was on 2013, push enter, 2014, 15, 16, 17, 20. Oh, sheesh. I lost count. This method could work to find 2049, but if you lose count, like I just did, then you're sort of stuck. So let's use our formula. Okay? So if I want to find 2049, what term will that be?
40.
Close. 41. But I'm actually ecstatic that you said 40, because it points out that these ones play tricks on your mind. 2049, which will be, oh, I'll do it green. 2049 here, do you see that you really like to do, 49 minus 9 is 40. So it should be term 40 because I did that way, right? But it messes you up that way. And you, like I've taught math forever, I feel like I always have to double check these. And the way that I double check them is I go to the easy ones. Okay, well if I do 10 minus 9, I get 1. But it was term 2. Oh. If I do 11 minus 9, I get 2. But 11 was term 3. So if I do 49 minus 9 and get 40, it's going to be term 41. And I know my term 1 is 30,000. I know my R is 1.008, and 41 minus 1 would be 40. I type this into my calculator. There's your exponent button, the 40. 41261.2, uh-oh, quarter of a person. Please run. But we're gonna round it. Anyways, something I like to show when I'm doing my work. 41261.2 dot dot. I sometimes show like a dot 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 there to say I know that number keeps going, and then when I round it, I can use approximation signs here. We get approximately 41,000 people. So I'm going to get you to circle 10, 13, 14, and 15. And we're actually going to do 15 right now together. Just because it's in section C, so it's a little bit harder, and there's a couple things I want to point out. So turn to question 15. There we go. Oh, I grew up on a farm in Saskatchewan, so this is farmer in Saskatchewan wants to estimate the value of a new combine after several years of use. A new combine is worth $370,000. This textbook is getting old. We did a little check with inflation. Now some combines cost $1 million. That's very, very expensive. Okay. Estimate the value of the combine at the end of each year because it's depreciating by 10%. We're going to make a chart here. End of year and value. And I'm going to find end of year 1, but I'm actually going to put a 0 in here because it starts off at $370,000. And percentages, depreciating by percentages, this is a good skill to be able to do because some of you like shopping. And if you like shopping, you like it when there's deals. And what are some deals that you sometimes get? You get a percentage off, right? So if a store was advertising 10% off, how do you do that mental math? Do you know how to figure out 10% of something quickly? You know this? You know the trick to figure 10% quickly? Divide it by 10, or just move one decimal place over. So 10% of $370,000 is $37,000. So I could take $370,000 and subtract 37,000 and get $333,000. So the combine has become $37,000 of that less the next year. Okay? The nice thing for the farmer, so if you want to become a farmer, if you buy an expensive piece of machinery, you actually get this depreciation value as an expense. You can count it as a tax write-off. So that's business-wise, this is true for lots of businesses. If you buy things that decrease in value, so if you need to buy a nice truck for your business, you're allowed to take off how much it depreciates as a business expense. Now, to go from here to here, we're going to be making a geometric sequence. Does it make sense that if you take off 10% of something, you have to pay for 90% of it? So if you check on your calculator, if I would have started with $370,000 and said, what is 90% of $370,000? I get the same answer. And at the end of year 2, I can multiply by 0.9 again. So if we figure out this multiply by 0.9, it's a lot quicker than multiplying by 0.1 and subtracting. You do both of those calculations at the same time. So I push enter here at the end of year 2, 299,700. How many years did they want us to do? 5. Oh. I think I would have got the point if they said 3. But anyways, we'll do all 5. And again, my calculator, I'll set it up so I can just push enter. There's year 3. Enter. There's year 4. Enter. There's year 5. But I have to write them down. Can you do this with your calculator? Just touch the screen and drag it to your notes? That's cool. All right, that way I don't have to flip back and forth. So I'm going to write them down. 269,730, 242,757, and 218,481 and 30 cents. Delete that now. So at the end of the 5th year, it's worth $218,481.30. So this is part of the, like in a business, part of the incentive of, oh, I can buy, like I said, some combines are $1 million right now. I can buy that combine for $1 million. And the amount of money that goes down is a business expense for me every year. So that helps me with my taxes and how much money I make. And then when I sell it 10 years later and I get my money back, then I haven't really lost any money along the way. I just had expenses along the way. So this R value is 0.9. Now, what type of sequence is it? So we can answer part B. This is geometric, since there is an R value and it's equal to 0.9. Predict the value at the end of 10 years. So since we have a sequence, we can make a general term. And in this sequence, I would probably start with the 370,000. That would be term 1. This is term 2. This is term 3. So my formula, term n, is going to equal term 1, 370,000. My r is 0.9 to the n minus 1. So there's my sequence formula. And then this is where there's a common mistake. So common, the textbook did this question right in this situation, but then the textbook made for teachers like a way to get a whole bunch of questions to give to students. And every question in that, the textbook made the most common mistake that students make as well. Which term, if I want to find the end of 10 years, which term am I going to find? Term 11. What do you think the most common mistake is? Term 10. Ugh. So I want to find term 11, which will be $370,000, 0.9, 11 minus 1 will be 10. I can type this into my calculator. And the nice thing about the graphing calculator is you can type it exactly as you see it. 129, 11. How many cents? I don't even include cents. And 2 cents. So at the end of 10 years, this combine is only worth $129,000. Right? I'm kind of curious if you wanted to buy a 10-year-old combine right now. Right? How many parking spots would you have to pay? Could you get away with paying only for one? You only need one parking pass, right? Even if it takes up 10 spots. So here, like, forget driving to school in a Lamborghini, $1 million. Get a nice new John Deere combine. Everybody would be like, whoa, so amazing. I guess it doesn't quite have that same status thing.